Hi, this is Mr. Urrego. Today we're going to find the domain and range of a relation. The relation is given by three order pairs. Okay, three order pairs. That's my relation right now. So the first question is find the domain and range of the relation, and they give me the order pairs. And the second question is determine if the relation is a function. Okay, so let's answer first. So domain and range. First of all, my domain are all the values of x. Domain of any relation of any function is all the values of x. So I have an ordered pair. I know this is x, this is x, this is x. The second value is y, y, and y, right? X, y, x, y, x, y. So my domain are all the values of x. So I just need to list all the values of x. The first value is -3, -1, 0. Done. That's your domain. The range, all the values of y. All the values of y. So I need just to list all the values of y from my relation. So in that case is -2, -5, -6. Okay? If you have a table of values, the same thing. You have a table of values. If you have a table of values, your domain are all the values of x, your range all the values of y. It's kind of the same thinking. All right, now, second question is determining the relation is a function. How do we know if a relation is a function? So an easy way how to do it, and hopefully you're going to visualize it better, is let me rewrite this relation in a t-table or table of values, whatever you want to call it. So I have -3, 2. I have -3, -2, -1, -5, 0, -6. I can write my relation in a table of value as well, and it's the same thing. Okay, so I just wrote it like this so you can identify better. How do I know if a relation is a function? The definition of a function is for every x there's only one value of y. For every x there's only one value of y. In my case, the -3 has a -2, only one value. -1, -5, 0, -6. So this is a function. It's a function. Another way of seeing it is when you have a table of values, check if there's any value of the x repeating. If there's no value of x repeating, then it's a function. If there's a value of x repeating, it's not a function. Let me give you an example of something that is not a function. Let's pretend that I have a table of value. By the way, that problem is done. So this is a function, and we have the domain and range, and we're done. Let me give you a different example when something is not a function. So let's say that I have three values as well. Let's say that I have -3 and -2, then I have -1 and -5. Okay, but I also have -1 with 3. Okay, so look at this. The definition of function is for every x there's only one y. The -3 has the -2, but look at the -1. The -1, let me try to erase that completely. -1 has a -5, and -1 has also a 3. It has two values. Therefore, this is not a function. Not a function. Alright, so that's the idea. How to look fast or how to identify better is check if there's any value of x repeating. Is there any value of x repeating here in the table of values? Yes, I had a -1 twice. Because of that, it's not a function. Okay? So that's a shortcut. Alright, so that's basically it. Yeah, thank you for watching.